So more and more 3D printed stuff is making its way onto my reloading bench. Everything from simple little things to help me stay organized all the way up to major component redesigns that make stuff work better. It's all brilliant and I want to be a part of it. So recently I reached out to my audience and asked them what 3D printer they recommended. There were a ton of different recommendations, which I see as a good thing. I guess it means there's a lot of people out there with a whole lot of different products finding success. As you can see, I ended up going with the Ender 3 S1. This printer hasn't been on the market very long, so it includes some of the upgrades and features that people are doing to the earlier Ender 3 printers. If I wanted to invest a little bit more time into this, I think going with the Ender 3 Pro or the Ender 3 V2 might have been the better choice, because I get those and then I just immediately order a couple of upgrades and I'm able to order the exact upgrade I want. So I may have ended up in a better, more capable printer for pretty much the same money if I had gone that route. But it would have been a little bit of hassle, right? The learning curve would have been a little bit steeper if I'm taking it out of the box and immediately upgrading and installing things that I don't really understand yet. On the other side of things, a lot of folks made a really convincing argument for the Prusa, the MK3S Plus. And it was just more money than I wanted to spend. And the lead times were going to be like 5 to 8 weeks. So I decided to stick with the S1. I'm not currently planning to make anything to sell. That's not really what this is about. If it was about that, like if I had some design, like I'm going to make something awesome and I'm going to sell it, I probably would have gone with the Prusa and, convinced myself that I could make up that additional cost with all of the amazing stuff I'm going to sell. So beyond those three choices I bring up, like I said, there were a lot of other recommendations. So it seems like a good time to be getting into 3D printing. I'm hoping this is going to be pretty straightforward. So the plan for this video, it's in a sealed box. I want to take it out, set it up, do our first test prints, get comfortable with it, feel like we're printing halfway decent, and then I want to design something. I mean, even if it's a box, just something straightforward, because I don't have any experience with any of that either. I played around for like 20 or 30 minutes on Tinkercad, and there are several other entry-level 3D design options we might look into. I don't know. We'll go through all the slicing software and whatnot that we need to deal with to print that design. And that's probably about it. That's probably what we'll cover. I have picked up 3 different types of filament. This brand is Inland, which I think this is the house brand for Micro Center where I bought the printer. Now, I don't really know enough at this point to tell you much of anything about the differences between PLA, PLA Plus, and PETG, but we're going to try all 3, and maybe we'll just figure it out together. Okay, no surprises here. Something I saw mentioned in the videos I watched was that this installation manual has extremely small font that's pretty difficult to read, so that's useless for me. So I printed out a full-size copy. It's only like 10 or 11 pages, and that just makes things much more easy to deal with. A copy of the manual did come on the SD card. Yeah, they send a little 8 gig SD card with manuals, videos, and some initial test files to play around with, along with probably outdated copies of their software. So actually, we're going to go ahead and put it in the slot here for safekeeping. It's as good a place as any to keep it. They send a card reader, so that's nice of them. So 4 bags of screws for assembly isn't too bad. And what's nice is the little baggies are well labeled. So that makes things pretty simple. All right, I think we got all the tools to put it together. There were some various spare parts. It's like a spare nozzle. I think there's a Z-axis limit switch and a cable of some sort. Now, people had warned me that this wasn't really well documented, but I'm kind of shocked. Because this is it. This isn't, it says quick installation guide. There's no full manual that I saw on the card. Maybe there's something on the website. We'll check later, but you're not going to get many details. And I just get the feeling that figuring crap out for yourself is one of the charming things about 3D printing. You can't be holding people's hands and letting the hobby get popular, All right, product installation step 1. Place the nozzle assembly on the mounting back panel of the extruder. Okay, so it looks like 1, 2, 3, 4. Those are our screw holes here, but I wanted to show you guys, this is the only place so far I've seen something be a little bit janky. Looks like this maybe got bent, and that connector is definitely not sitting flat on the board. So I'm going to go ahead and kind of straighten it out a little bit. I guess it's okay. These are pretty thick wires because I believe this is the actual heater, right? There's our little nozzle where our plastic's going to come out. So a fair amount of current in those little guys, and they're very rigid wires, and I think that might be what's kind of tweaking that a little bit. All right, I think we're okay. Yeah, it sits right down on there. With this next step, I don't even understand what they're saying. I guess this little clip slides on there. Okay, next, gantry frame installation. All right, let's kind of test fit this thing just a little bit. Yeah, that's about where it needs to be. But I guess I need to lay it on its side. Or maybe slipping it to the edge of the table here would be easier. If I can find the screw holes, there they are. Yeah, I think this edge of the table method here is going to work out pretty good. I'm not going to tighten those very much yet. Let's flip it around and get the other two. Tell you what, that base is a lot heavier than it looks. So I'm not fully understanding some of the instructions. Like it said, rotate the bottom assembly by 180 degrees to ensure that the profiles on both sides are leveled up and down. I don't really know what they mean by that, but yeah. Both sides went down into a little slot, kind of. Yeah, you can kind of see that silver spot on the base. I guess it would be possible not to get it down in that slot. Maybe that's what they're talking about. Yeah, I don't know. I think I got it good. I'm going to tighten it down. So our little holder for the display is these 3 holes. Nice set of T-handle Allen wrenches would make this process a little bit easier. Okay, there's our display holder. And it's got 2 big old ding-dongs hanging out the back that slip in. That sounded weird. Okay, it's fine. Just has a nice crispy sound. So I guess next here is our material rack. That's our filament runout sensor. And I guess this handle just goes in like that. Okay, and I guess this just snaps onto the top of the bar like that. And then we start plugging stuff in. Here, I guess, is the wire for this. And I guess the routing of this main ribbon cable, yeah, there's very little info about cable routing. This one picture here has some cabling in it, but every other diagram of the machine shows it with no wiring. Like here, this is in the future. We're loading our filament into a printer with no ribbon cables. That's helpful. All right, so there's this big one, like flat 24 pin or something like that, clearly goes into this dude. Yeah, the connector goes right there, and clearly this is supposed to go down in here, I guess. At least the connector's keyed, so I know I'm not putting it on backwards. I really want to drop this thing, like lower the Z-axis, but I don't know if that's going to screw something up. Whatever. I need more room to work. What I'm worried about now is that when I turn it on, if it thinks this is higher and it goes to home, like all the way down, I don't want it to crash into the printing bed. So I think once I'm done with this cable, I'm going to try and raise this back up all the way. Okay, I think I got it under those tabs. Yeah, I'm happy with that. Okay, so this is the connector we just put on. I turned the machine pointing away from me, and if we follow it down, there's these 2 pigtails coming out of the ribbon cable. Even has a little X label on it. So that should plug in right here. Now I got this all wrong. These are the Z-axis motors, right? Obviously. The X-axis motor is this guy over here. So this plugs in right there. And that little clip we installed earlier is strain relief for that. Okay, that makes more sense. Where does this other little guy go? That's where the second connector goes. One on the back, one on the front. I'm going to go ahead and raise this thing back up. Okay, there it is all the way up. I was just wanting to make sure that wasn't going to pinch. So hopefully that's routed correctly. And okay. Then straight below that, looks like the cable we need to plug in here is taped back here. There it is. similar thing over here on the other side. Got a little cover here. There's our other Z connector and a little 3-wire job that goes up to our filament detector. And this one in the middle is labeled expansion interface. So I guess we're not using it. All right, and then the back of our display gets this guy. All right, I think that's it. I've got this one leftover bag of screws. I need to check the instructions and figure out where I was supposed to use those. Okay, so these screws are not talked about at all in the manual, but they're identical to the screws in this spare Z-axis limit switch. Or I shouldn't say spare. One of these is just not installed on the Z-axis. And I was looking, there's one back here for the Y-axis. Looks very similar. And up here for the X-axis. But what I think's going on is the auto leveling setup maybe serves some of the same functions. Because, you know, the next step, we're about to power it up and go through the auto leveling. And the instructions say, please use the CR Touch auto leveling first, which is this little guy right here. It says, if CR Touch is damaged, please install Z-axis limit and manually level the bed. For details, please refer to the instructions stored on the SD card. There's nothing on the SD card. So I'm just going to move forward being optimistic that everything's fine. But I might look into it and see if there would still be advantages to installing this. Because this doesn't go here. As far as I can tell, it mounts over here. Let me go ahead and bring this thing down manually. Which actually, this is not a bad idea anyway. Just to make sure our ribbon cable is going to do what we expect and not going to hit anything. And I want to be really careful as our nozzle gets close. That's close enough. But yeah, I guess this would be installed here, and this carriage would be coming down to hit our switch. And then I think this cable connects this to the main board down below, I guess. Yeah, it looks like I did route this cable incorrectly. That's for a round cable. There's a slot here I didn't notice where it looks like this will slide down in. Yeah, I think that's better. Okay, one more important thing before we fire this guy up. We need to make our selection between 230 and 115 volts. And that is really back in there a ways, isn't it? Yep, right now it's on 230. It's just a little slider like usual and looking good. Okay, I think we're ready for first power up. I've moved the Z-axis all the way to the top. I guess we can go ahead and peel this off the screen, which that screen protector has a warning about the voltage switch on it. All right, here we go. Okay, looking good so far. Instructions say to go to level. Interesting, down there at the bottom where it shows our X, Y, and Z position, it's flashing question marks. So all right, as soon as we hit this, it should see, automatically returns home for automatic calibration of 16 points, and then returns to home again to complete the leveling. Here we go. Okay, that was a little bit loud. So it went all the way to those X and Y limit switches and clicked those, and then our Z is coming down slowly. I'm ready to jump for that power switch if it comes down and just starts jamming into the bed. Okay, good. And then I think it said it would go home. All right, so I guess that's that. I need a sheet of paper. Okay, the next step is to go to Prepare and go to Z Offset. It says to adjust the Z-axis compensation value so that the height from the nozzle to the printing platform is about the thickness of a piece of A4 paper. Click the knob to confirm, complete the setting of Z-axis compensation value. Okay, so right now the value says negative 2.83, and I don't know which direction is up. Yeah, there it went. Okay, so I made it less negative. It was negative 2.8, I think. Now I'm at negative 2.75, and the paper started sliding under. Negative 2.78. It's getting draggy. 2.79. 2.8. 2.81. 2.82. I remember a video I watched, they were talking about that, like, you know, if the paper bends like that, that's a little bit too much. Yeah, negative 2.81, I'm bending sometimes. But negative 2.80 seems okay. All right, so I'm going to click there to confirm that. And I think we're good. The next part in the manual is auxiliary leveling. It says that if the inclination of the printing platform is larger than 2 millimeters, the automatic leveling will fail. Please use auxiliary leveling. And that's where you start cranking on these 4 wheels under here. But we're not going to worry about it. Ours didn't fail. I guess now we need some filament. So it's kind of late, but for a quick test tonight, I think I'm just going to open up this little bit of filament they send, and we'll just try and print one of the pre-sliced files that's already on the card. I definitely expect it to fail spectacularly, so I guess that just hangs on there, and then this goes through the sensor. And we come down into here. I think we push that down. Okay, that went in pretty far. I feel like there's some preheating we should have done. Yeah, let's try this preheat PLA. Which looks like the bed temperature says 60, and I guess that's the nozzle temperature is set to 200. They do provide this material guide with the temperatures and crap, which I guess is for the stuff they send, and 6200 looks like the correct settings. Yeah, it looks like we're getting a little snake of melted plastic coming out of the bottom now. All right, here goes nothing. Let's just go. Oh, I need the SD card. Okay, now there should be something in here. Shake hands, rabbit, handle. Let's do cat. I have a cat. I like cats. Oh, something's happening. Okay, we're laying down plastic. Definitely got some spaghetti going there. Like, holy crap, it's kind of working. That first white outline is maybe squished down a little bit more than it should be. I'm kind of in shock here. Like, I didn't even wipe off the surface. I know getting adhesion on the work surface is a big deal, and I think I was supposed to clean this off with alcohol. Or something. I didn't do anything. I honestly didn't expect to get this far. If it's going to go ahead and run, I guess we could look through the menu. Because there's tune, pause, and stop. So let's go and see what's in this tune. Okay, so we can adjust our printing speed, our nozzle temperature, bed temperature, everything. Yeah, looks like mostly pretty straightforward stuff. It's like it's calculated a remaining time, 4.5 hours. It's like midnight right now. This was a bad choice because like letting it run unattended seems dumb, but I don't really want to stay up half the night. But it seems wrong to cancel its very first print job, you know? Okay, so we are 27% done, 1 hour and 11 minutes into it. This is the only problem I've seen so far. I'm not really sure how you're supposed to handle this, but I'm not really worried about it because we're going to have spools. So not sure why they don't put this on a little spool. Tell you what, some of the details coming out on the front of this print are blowing my mind. Like, that looks really good. And that severe overhang we've got between the cat's feet there, that seems to look pretty good. Once we get into slicing, I think that's going to be, you know, a big topic, because you can't lay down plastic in midair. So those overhangs like that can be tricky, I guess. So we'll get to that later, I guess. So 3 hours remaining. I think I'm in for the long haul. We are down to the last 2 minutes. I am shocked by this. We didn't even check the belts on this thing to make sure they were tensioned properly. We didn't update the firmware. They are pretty mesmerizing to watch. It's pretty awesome how all of those small details are even possible. Looks like the last few lines. There it goes. Man, that is awesome. So it's asking me to confirm here. Okay, that puts us out to the main screen. So it looks like our nozzle temp is dropping, and so is the bed temp. I assume I should probably get this out of here while the nozzle's still hot. That's what I'm going to do. I don't know if it's right or not. I think I can do that maybe. The kit does come with this little acupuncture needle sort of thing. Try and poke it down through maybe. Whatever. That's good enough. So it's definitely not perfect, but I'm totally impressed for an unconfigured printer. That is really cool. All right, so I got a little bit of sleep. So let's get our print off of the work surface. The first thing I wanted to kind of just check and see is make sure it wasn't loose or anything. It feels like it's well adhered. So this whole black part here, which I believe is spring steel, just pops right off. So I think I'm supposed to give this a little bit of a bend, and there went something. I'm not sure, it might be better to take these off while everything's warm. All right, so I just cracked it right there. I was thinking about this last night. These two pillars below the hands, I'm not sure if those are supports that are meant to be popped off. I think they are, because as it was printing, I was noticing the quality on those. You know, you can definitely see the lines and stuff a lot clearer than you can on the actual body. All right, let me keep on bending here. There, I think that was, it was a good pop, but didn't quite get us free. Man, that did not want to come off of there. Then our two supports, yeah, that one didn't quite. I guess that's why the kit comes with this. Looks pretty sharp. What about this single line? I guess I'm gonna have to go do some research. Okay, managed to get the putty knife under that guy. Okay, after a little bit of scraping, that's what I'm left with. We definitely got good adhesion, right? We'll have to look around and find out what the normal procedure is for cleaning these. So I do notice a couple stringy little wisps, but definitely not bad. That should like brush right off. Let's have a look at that overhang that was impressing me as it was starting. Yeah, right there. That is really, really cool. Got some more little wispy hairs in here. I am really happy with these fine little details. Very cool stuff. Now the clearance between these posts, the support posts, which actually probably ought to look at that right where those popped off. I can't even tell where it was attached on that side. That side's got a little bit of a rough spot on it, but not bad at all. What I was going to say is whenever they were attached, the clearance there was really, really tight, but I don't really see any marking. Maybe there, maybe that's what that's from. Nothing on the other side. All right, extremely successful first print. Could not be happier. So I'm not going to be able to work on this for a couple of days probably. So what I want to do is go ahead and use up the rest of this filament that came with the printer by just printing out a bunch more stuff that's already on the card. Tell you what though, before I start another print, I better research a little bit on cleaning that guy up. Okay, so I learned a couple things. There are a bunch of people with build plate cleaning videos, and most of them are kind of useless. they're dissolving glue with alcohol or just wiping off dust, basically. And then the comments section of all those videos is a bunch of people with our problem here, where I got PLA stuck on there, and those conversations were much more useful. So I really should not have gone at this thing with the scraper like I did. You can see I've lost some texture in that middle part. I mean, I think I'm okay here, but that was a very stupid thing to do. Apparently the right way is really to heat up the bed and then clean it off. But a lot of people said, as long as you get it to where it's not anything significant, which, you know, this is nothing, it'll probably release and come off with the next print. Now, the reason for this was that I had my x-axis offset too high. Let me get this thing back on here. It's a pretty powerful magnet. So yeah, if you remember back to where I was setting the height with the piece of paper, I should have gone a little bit higher. This first layer just didn't have enough room between the nozzle and the bed height to lay down that nice bead, or it's kind of a squished bead a little bit. Mine was flattened out and smushed into the build plate. So another thing I want to do before I continue my test prints is go ahead and check the firmware and update it if it's needed, which I'm pretty sure it will need it. So let me turn it on and we'll get the current version, which is probably under control. So let's go down info. Okay, current version 1.0.3c. Okay, so there's a 1.0.5 available on the website. So I downloaded it, unzipped it, and put it in a folder on here. I'm wondering whether it's going to need to be in the root directory. We'll see. I'm sure there's a million places to tell us how to do this, but I'm going to plug in the card and we'll just see what happens. And nothing happens. Well, that's kind of good, because whenever I saw this store configuration option, it made me want to try it. All it does is beep. Well, let's reboot this thing and see if it finds our files on the card. Nope, no such luck. Okay, so I grabbed a different card and dumped the files right in the root directory. Let's wake up our screen. There it is. All right, let's reboot it. Okay, that didn't work either. Let me go look up what to do. So apparently we were doing it right, but it did not like my other SD card. So I went ahead and deleted all of the crap off this card, or transferred it off to a folder on my desktop, and unzipped the firmware stuff onto here only. So hopefully this time we reboot, something different's going to happen. Well, it does seem to be taking an extra second. Info, there we are. Let me go put our print files back on the card, and we'll run through that leveling process again, see if it works as well as it did the first time. Okay, that completed successfully. So let's do our Z offset adjustment. I think that's about where I had it before. On mine, it's negative 2.78. I'm almost tempted to go a little bit too high on purpose, which we'll do that eventually. I want to go with it about right there. Little bit of drag on the paper, but a lot less than I had before. So what I want to do now is load my PLA. Well, I guess I should maybe set the temperatures first. Control temperature. Nozzle temp was 200. Oh, that's okay. I'm an idiot. Yeah, I'm a total idiot. So under control, I'm going to set all of this stuff back to 0. Yeah, all of that should have just been left to 0. Because under prepare, whenever you go to reheat PLA like I should have, that's when these are going to get filled out. Okay. It all makes sense now. So we're almost up to temp. Let me get ready to load the filament. And I'll tell you what, I'd like to have the nozzle up off the bed a little bit whenever I'm loading the filament. So I think I can go to move Z, and hopefully, I want to make sure I'm not going to ram it into the bed here. Yeah, positive numbers are moving it up. So I want to put it at, there we go, about 55. Leaves me some room to work. Yeah, it left a little drop of plastic there where the tip of the nozzle was. Okay, so much for heat up the bed, it'll come right off. Whatever. Okay, the filament's loaded, but what I forgot to do last time is you're supposed to cut this at an angle. Yep, supposed to snip it off into a point so it feeds through a little bit easier. So I'm going to pull this back and I guess just push this down in and until plastic starts oozing. And we've definitely got some oozing. Perfect. So let's start a new print. I'm going to go back. Let's auto home. And let's just print the exact same thing. We'll print the cat again just to make sure that this firmware version does just as good a job. I can already tell that looks taller than it did. Not squishing it down quite as bad as we were, which is good. Yep, I think that's better. Okay, so I'm going to let this run. If it goes just like it did last time, I'm going to move on to the next generic file that's on the card, and I'm just going to print over the next couple days until I've got time to work on this a little bit more. So if everything goes well, I should see you here in just a second with a whole bunch of stuff to look at. So I've kept the printer running almost non-stop over the last few days, and I've finished 13 prints. So the original little bit of filament that came with the printer, it lasted for 3. So I made 2 cats and one of these weird handles. And then I had to switch over to my box of standard PLA. So the one minor change I made was to bump up the temperature. You can see this stuff says 215 to 230, and with the original stuff we were using the default temperature in the profile, which was 200. So initially I'd switched to 220 degrees, and eventually I started playing around a little bit, and we'll look at those really close. I want to compare, like, yeah, there we go with these. I've got ones that I printed at different temperatures. We'll go find some better lighting and look at them closely. So here's my last one still on the bed, and this one's been sitting here almost 12 hours since it finished. So this is a problem that's stuck with me, is getting these things off of here. Well, getting the work piece isn't hard. A little bit of flex and it'll come right off. But getting these thinner layers off has continued to be a struggle. Yep, should be able to just crack it right off like that. And then with these, especially the straight one, I can usually find a spot where it'll lift off like that. And more often than not, this gets the whole thing. Not always, but usually. Yep. Almost. All right, straight line's usually the easy part. This one is where things get tough. I usually just have to go around and kind of test it at different spots. There, like that. And then this will probably come right off. Almost. The worst one I had was the highest print temperature I tried. This 230 degrees was a nightmare. Had to do some scraping, and I ended up gouging the surface somewhere. I can't, there it is. I dug my putty knife right in there and damaged the surface. I don't know if these build plates, or whatever they call them, are supposed to have a finite lifespan, but this seems like something, Well, I'm gonna at least need to replace it once, probably. Okay, I wanna kick off one more print and show you how I've been adjusting temperature. So I'll just pick my print file, which is this little chip. Let's print one of these. Click OK and it'll start. So the first thing that happens is it begins to warm up the bed. And right now you'll see the nozzle temperature is 0. So it's got a bed target of 60 and a nozzle target of 0. What I found is if I set my nozzle temperature now to like 220, remember the range on our new box of PLA was 215 to 230. So I want to set it to 220. If I do it now, it'll overwrite my change, or at least it did. I got the timing wrong one time and my change didn't take. So I always wait for the bed to get up to temperature first before messing with the nozzle. All right, so it's getting up to its target, and we should now see the nozzle temperature. There it goes, 200. So once it's set itself to 200, I go into tune. The second item down is nozzle temperature. Let's change that to 220. Click OK, and go back out to the main. And now you'll see we're at 220. So the printer's not going to do anything until it hits both of these targets. And I guess that's one thing I didn't understand early on, is I thought that entire prepare menu and preheating stuff and everything was something, you know, we needed to do manually, and it doesn't seem to be the case. So we just hit our nozzle temperature, which means our printer should wake up here in just a second. I haven't gone through any bed leveling procedure or anything since we did it right there at the very beginning. So it lays down those 3 strips on the left and then moves over to the center and does the little outline. And then starts printing. Okay, let's have a close look at some of these prints. A little bit of the wispy stuff. Put a white one right next to it. So some of the flaws, like at the top of the mouth and the bottom of the nose, seem to be on all of the prints. So that tells me it's not necessarily any issue with the printer, it's the way it was sliced, or other settings like that is what I'm thinking right now. Have a look at this overhang here. That part's pretty surprising, and I think I'm going to have a lot to learn as far as what the capabilities of the printer are as far as horizontal portions and what needs support and what doesn't, right? This support here that's trying desperately to come off, we'll go ahead and pull it off. The reason that's needed is because there's no other way to print something that's that close to horizontal. There's a look at that tight little space between the support and the actual print. Let's go ahead and pop that one off as well. A lot of these small details just blow me away. So all of the cats came out equally good. The 2 white ones were printed at 200-degree nozzle temperature, and then this was a 220. So let's move on to some rabbits. There's some more stringy stuff. And that weird line right below the eyes shows up on all 3. I guess that's another one where, you know, if we wanted to clean that up or get rid of that, it would be a job for the slicing software, not our printer, at least I think. So I wasn't able to find any significant difference between these. You see, like the numbers, this was the 6th piece that I printed. I was keeping track of which one was which, but it got to a point where they were all coming out exactly the same. They were all coming out really, really good, in my opinion. So I stopped worrying about it. Here's the coin that we're printing downstairs right now. I think this one blows my mind more than any of the others, because this side right here is the one that touches the surface of the build plate. So it was built up from there. So I'll be interested once we pop this file open in the slicing software, just to like, how is this not printing over top of thin air? You know, this part right here. Or if you imagine one of the lines that's above the B, like those lines of plastic had to span all the way from there all the way over to there. So this little print is pretty darn cool because it's showing off stuff that I didn't even realize was possible. Now, huge texture difference, right? I wonder if we actually could separate any of the individual plastic strands. It doesn't look like it. No, it all seems to be melted together, but pretty rough texture when we compare it to the other side. So then comes the handles. Not sure what this handle's for, but it looks to me like this part right here is just support, and we're meant to snap that off, I believe. But before we do that, let's, actually the khaki colored one might be a little bit easier to see what's going on. It's pretty neat stuff. And the texture on the handle's pretty neat as well. So let's see if we can crack that part off. See if we can just slide a screwdriver in there. Nope. There we go. Maybe this corner. Okay, there's half of it. Maybe this is what that putty knife's for that they gave us. So I guess that's pretty cool. Here's the back side. It's got some squiggly garbage on both sides as well. Let's see if the other example we've got has that. Yep, it sure does. Exact same thing. Tell you what, let's see if this brand of PLA cracks off a little bit easier. It did. So that cracked off and scraped off a whole lot easier. It's got me thinking maybe that's going to be an important thing when you're using large support structures like that, getting the temperature just right so it releases properly. I could see that being important. So yeah, these are pretty boring, pretty straightforward, and I think the printer did what it was told. Now comes in these handles. We'll look at this one first. I think this might be a handle for the top of the printer. Maybe some of that extra hardware they provided would allow you to attach this up where the filament spool is and have a little handle for your printer maybe, I don't know. So the first couple flaws that jump out at me, I'm pretty sure this is the first one I ever did. It was this stuff, which I think the most common cause of this is just the nozzle being a little bit too hot and oozing more than it should. And this also has breakout support structures here on the side. I'll tell you what, let's see if we can get this first one out of here. I have a feeling these are going to be a pain. There it went. That's a pretty cool looking structure. And it actually seems to have broken free pretty cleanly. Pretty cool stuff. All right, here on this side, a little bit of hairy stuff, or it's not going anywhere. It's there. It's just a little bit ugly. This would have been the top of the print. So like the last passes before it finishes are right there. If we flip it around to the other side, we see a flaw in the E, and that same flaw is on every single one that I printed. So I'm not sure if we're supposed to pop this out. If this is actually a little support. Yeah, I think that's what it is. How about that? Figured that was the case. So after I printed the first one, and I was already using the new filament, and I saw these, and I saw these, and then over here underneath there's a couple more. That's when I decided to start messing around with the temperature a little bit. So at this point, I'm printing at 220 degrees. This one was printed at 200 degrees. So this is 15 degrees less than what our filament calls for as a minimum. This is what, it was kind of an accident, like I was talking about earlier with the changing the temperature on the fly. My settings got overridden, but when this thing finished, I'm like, well, okay, so we're definitely not too hot, but I still have those exact same two nibbins up here, and then a couple of more down there. So here's the last one we were looking at. You can see they're still there. A lot of them seem to, line up in the exact same spot, but then again, there's some that don't. The ones on the top definitely seem to. So I thought, okay, what if we go the other direction and go as hot as we possibly can? So 230 was the max listed on that filament documentation. So here's 200 versus 230. So all right, 230's on the bottom now. Not a whole lot of difference. It's a pretty big temp swing. I expected something. Definitely got more of it over here. This is 230. Top is 200, bottom is 230. Quite a bit of difference on this side. Little bit of change on the other side. But you know, they're both good prints, I think. Let's see if we can pop them out. All right, let's do the 230 degree first. It came out. It wasn't quite as eager to come out as that last one. A little bit of leftovers in there. All right, now the 200 degree one. That maybe came out a little bit easier. And I think the texture difference we see here, yeah, it's because they're reversed. I need to pop out this side. There we go. So 200 on the left, 230 on the right. Swing it around. Listen, I'm sure 3D printer nerds probably agonize over some of the little differences we're seeing here, but this seems like nothing to me. It really goes for all of the prints I've done so far. Like, they all seem really good. So folks, we got nothing but success so far. I printed a bunch of these because this was the longest job on the card. I think this took 4.5 hours or something like that. So between all of this stuff, I mean, I've probably got 30 hours or so on the printer. I'm not sure if that's a thing to count, but print hours, like 30, maybe even 40. And I don't have a single failure or major flaw to show you. That's pretty exciting to me. All right, now let's find something else to print. Oh God, anything else. I'm so sick of printing these same couple things. All right, I got my comically huge cursor and I think we're ready. On the Creality website, under support, we can go to download. And back to our firmware upgrade, right here is Ender series firmware, S1, and then here are our files. So you end up with a zip file, and then when you extract that, you're left with this folder right here. So these two folders and these two files are what I copied onto the SD card, not the whole folder, these individual things. So if you open up the SD card, this is what you would see. And that's what worked for me. We just plugged it in, turned it on, and we were done. Now back to the website under software, I want to grab the Creality slicer. It's like this is the Windows version and this down here is the Mac version. So what I'm downloading now is 4.8.2. So let's compare that to what came on the card. So everything that was originally on the SD card, I just copied directly off into this folder. So this is what we get, all of the G-code files and the STL files for the prints I've been making. But up here under software and drive, Creality Slicer 4.8. Yep, 4.8.2 build 191. So what we're downloading now is build 205. So a little bit newer, I guess. So here's that zip file I just downloaded. I'm going to extract it. So here's that folder. And from other videos I've seen, it's just a basic Windows install. Click next and yes a couple times and you're done. Looks like there is a point here where we can choose some different components. And it looks like a lot of file type support. So the only one that's checked by default is Open STL files with Creality Slicer. So I think that's the standard file format we normally work in, but once you export from the slicer, it creates a G-code file. That's why back to our SD card, we've got STL files for each of the things I've been printing, and we've also got G-code files. So the G-code files are what the printer is using. So my understanding, basically we open the STL in our slicer, slice it, and then output the G-code file for the printer. So why wouldn't we want to be able to open G-code files with Creality Slicer? I mean, I guess if something was sliced in another software, it might present problems. I don't know. I want to go ahead and check it. It's better to have the capability and not need it. Looks like it's wanting to install some serial drivers. Sure, why not? Arduino drivers, sure. And we're done. I got a firewall pop up and it looks like we're good. Now I will say I've had a lot of people recommend that I use the Prusa slicer instead of the Creality slicer, so we may not spend much time in here, but I just kind of want to open it up and try it anyway. Please take these steps to set up Creality slicer. Okay, get started, sure. Disclaimer, they're going to steal my information and sell it to the highest bidder like everybody else in the world, sure. And here, I guess, is the main reason I want to use Creality slicer first, because we need to pick our printer out of the list. So here is the Ender 3 S1, and I think this is going to fill in a lot of settings with default values that will hopefully be pretty close to what we need. And since I don't know what any of those are, might as well just stick with it. And speaking of those settings, I think this is what we're talking about. Yeah, width, depth, height, build plate shape, etc. G-code flavor. The default's set to Marlin. Not sure what that means. We're not going to touch it. Okay, over under extruder, let's see what this one says. Compatible material diameter, some offset stuff. Okay, next. Hey, we're in. I did see on another video this middle dialog here where you choose your material type and your nozzle size. If you shrink the screen, it disappears. So you don't see that unless you've got it at least that wide. So what I'd like to try and do is open up one of the files we've been printing. The file, open file. Here are the files on my SD card. So looks like we could open up the STL or the G-code files. Let's see if we can open up one of the G-code files. And let's do this one right here. This is that coin that I was so interested in. All right, I gotta figure out how to navigate in here. Let's see, okay, I can zoom. It's like a couple different view options down here on the left. So let's see, 3D view, front view, top view. Okay, let's look at this top view. Looks like my options are limited. Up here it's saying print setup disabled, G-code file cannot be modified. Let's go to preview and I wanted to see if it would show us the slices. Yeah, here we go. Okay, let's see if we can zoom in on this. Looks like I have to right click to move things around maybe. Okay, so here we can look at it layer by layer. So there's our first layer. I want to get up until it starts to fill in, you know, this gap right here. This is the part of that coin that just doesn't really make much sense to me. And right there it is. That's crazy. I still don't understand it. Like, it's doing exactly what I thought it's doing. It's just jumping the gap all the way across. So I guess all of that sagging and rough texture is just how it is. Huh. Pretty neat. All right, let's open up this exact same thing. All right, so let's close this. Can't see anything with this giant cursor. Okay, I see new project and save project, but no close project. All right, screw it. We'll just go open file. This time, let's get the STL file. Okay, now I'll tell you what, let's go back to the prepare portion of things and let's go back to my standard view. Can't really see much, can you? All right, well, down here on the right, let's go to slice. Okay, slice complete, and it's showing this is an approximately 28-minute print. So let's go to preview. Okay. Looks like there's two view types. Layer view is what we're in now. Let's look at the X-ray view. Okay. I think a tiny flat coin, probably not the best choice here. We'll switch over to something more interesting here in just a second. Okay, so we can choose which types we want to see. I guess this would probably be important on a print where you have a lot of infill and wanted to see. I guess, you know, we just don't have any infill on this print. And let's see, standard quality. As soon as I change this, it looks like it killed our slice. So we have to re-slice everything. So the 0.2 shows up as standard quality. If I switch it to 0.28, it calls that low quality. 0.16 is dynamic quality, and 0.12 is super quality. I'll tell you what I want to try and do. Let's leave it at standard quality, but let me look here under custom. Looks like there's a bunch of other crap. Build plate adhesion type. Skirt, brim, raft, or none. So I think the skirt is the single line around the outside that we've been seeing, if we did a brim, I think that line would extend all the way to the actual object, and I think raft makes it thicker. I don't know. We'll come back and play with that maybe. Okay, here's what I was looking for, was the print temperature and the build plate temperature. It is affected by default printing temperature. I think that's what we need to do, is we need to find the default printing temperature. Okay, I think I found it. It's up here under Preferences and Configure Creality. And then it's under Materials. And here's all of our stuff. And then under Print Settings, it won't allow me to adjust that. Why won't it allow me to adjust that? I mean, I guess what we've got to do is we've got to select generic PLA and click on Duplicate, perhaps. It's warning me about things that are changing, but I don't see any change. Sure, keep changes. Okay, now I've got the generic PLA I just made. What was that brand name? Inland. We'll call it Inland PLA. And now I have an Inland option lower down here. So now let's see if I can go. No, it looks like you got one shot. Or maybe you can only mess with it when it's not active. Okay, I think that's what's going on. So let's go back to generic PLA and let's activate it. Sure, keep changes. Now my Inland PLA I can adjust again. So if I go to Print Settings, I could change that to 220. Build plate 60, everything else the same. Okay, just gonna look back through those settings and make sure everything else is the same except that temperature. Yep, that's it. So now my Inland PLA I'm going to activate. So now if I click up here and look at my settings, yep, print temperature 220. Good deal. So here's what I'd like to try. Let's slice this thing up. I'm going to save it to File. I'm going to call it First Slice Test and click Save. Now what's got me a little bit worried here, so my file is 1240 kilobytes. The file I've been printing is this one right here, this bit_ender_zi is the coin file. It's 1550 kilobytes. I bet theirs is maybe higher quality. So I'm going to go put this file on the printer and we'll let it run. Shouldn't take long to print. So I'm going to transfer it over to an SD card and we'll see what happens. Okay, standard quality, straight off the printer. I already see that big string right there. And just overall poorer quality. Here's the one from the file on the SD card. All right, let's pop this off and see how all those big bridges did. Yep, another funky string there. And a little more open space, I think. Oh, that's interesting. Laid them down in different directions. Now that we look at it again, it doesn't look worse, does it? No, if anything, those voids, yep, these voids right here on the original are not there on our new file. Interesting. There's the spot on the edge where I guess the nozzle probably changes direction. That's our new file. Here's the old file. Old file on the bottom, new file on the top. All right, a little bit confusing. If it wasn't for this, if it wasn't for that little guy right there, and its counterpart over here on the other side, I would say the quality is about the same. And I guess the lettering just being just crappier in general. Confusing results. I'll tell you what, here's what I want to do. Let's go ahead and try all of the different settings. So here's low quality. What happened to the simplified view with the sliders? I wonder if that's only under Prepare. No? Yeah, I'm not sure. But that's what I want to do. I want to create files on low quality, standard quality, dynamic quality, and super quality. And print each one out. So, all right, low quality, keep changes, and then slice. All right, there's coin low quality. And I'm going to go ahead and print standard quality again, just to see if we run into that same stringing or bridging. I can't remember which one they call that, but I want to see if we run into that again. So let's slice it and save it. Okay, so now I've got my 4 files, and the file size definitely does get bigger as the quality gets better. So if I go back to the original one that came on the memory card, it was 1550, and my dynamic quality is 1591. So maybe dynamic quality is going to be what gets us back to the original file. I don't know. Should be a fun test. Now, after I finish these, I also want something I can kind of let run overnight. And everything I've printed so far has been very short. So I pulled up Thingiverse, and I guess it's showing us things that have been popular in the last 30 days. Let's click through until something pops out at us. Not really seeing anything that's particularly tall. Let's just search vase. Nothing more generic for testing a 3D printer than a vase, right? Here's one that looks pretty cool. Spiral vase. It says it's 150 millimeters high. I think if we go to Thing Files, Spiral, Double Spiral. Yeah, let's grab double Spiral Vase 1.stl. I want to make a Thingiverse folder so I can try and keep track of where this stuff comes from. All right, let's open it up and see what it looks like. All right, let's go New Project and then open it up. Yeah, that looks like a good test. So we've got our inland PLA profile selected, so that should give us our 220 degree nozzle temperature. And which quality should we check? Oh, maybe if I click this recommended, there it is. What do you think, standard quality? Or actually, since I'm going to let it run overnight, so let's pick that dynamic quality. And let's see, adhesion, enable printing a brim or raft. This will add a flat area around or under your object, which is easy to cut off afterwards. Nah, we'll try it without it. Haven't really been having any adhesion problems, have we? Okay, let's slice it that way and see what it looks like. Holy crap. Estimated time, 1 day, 1 hour, and 57 minutes. Let's go over to the preview. See what it looks like. Seems pretty straightforward. It's just, I guess, kind of intricate and tall. Let's see if we switch to standard quality, how much time is that going to save us? And I have seen other people say not to trust that estimated time. It didn't really save us all that much time. 21 hours, 15 minutes, 4 or 5 hours. Screw it. Yeah, we'll go with that. Let's go with the standard quality. So, all right, I'm going to save this to file. Wonder what this file size is going to look like. 41.2 megs. Okay, good deal. I'll talk to you guys again when I've got all that printed out. Holy crap. So this vase came out awesome. All of the fine little details look great. A couple little strings down here. Nothing I'm going to worry about. Just really good stuff. And here are our 4 different quality coins. Start with low quality and standard quality. See, low quality, definitely looking pretty rough. Not too much difference on that side. But pretty big change on this side. I forgot to write down how long it took to print the low quality, but standard quality was 33 minutes. And the dynamic quality, which is really where we see a big improvement, it actually printed a little bit faster at 32. And the file size was bigger on this, so must have just been more efficient movement of the print head or something. So pretty big improvement there. And then if we look at dynamic versus super quality, see that one took 49 minutes. Not really seeing a lot. I guess here on the back, this is the dynamic quality and definitely got some texture there. But if we look at the Super quality, it's a little bit better, but not by all that much. They look pretty similar. Tell you what, let me line up all the seams. That is probably the easiest place to tell the difference. So I think the dynamic quality, that generic dynamic quality selection seems to be the best trade-off, because it was definitely significantly faster printing than the super quality, but a noticeable improvement over standard with little time change. I'm sure that'll change depending on the print. I'm sure there are other print jobs where maybe this is significantly longer. I'm not in a big hurry, so I think dynamic is the way I'm going to go here in the short term. That was so cool watching the printer lay down these big bridges. Really pretty amazing stuff. So what's next? So I printed these several days ago and then took a little time to edit this video up to this point to kind of see where we're at on time. I mean, this was always going to be a long video, but just kind of wanted to know where I'm at, to know how much more do I want to take on from this point. Because the entire subject of tuning the printer, like calibrating the extruder so that it's actually feeding the exact amount of filament that it thinks it is, and there's an offset we can change, the nozzle retraction distance and the nozzle retraction speed can be adjusted. We've already been playing around some with temperature. I don't think I want to get into any of that much deeper. But one thing I definitely do want to do is try out our other two types of filament. So the PLA Plus and the PETG. So what I'd like to do next is run all three of these through a temperature tower, which should give us a lot of information about each. And then I want to move on to designing something for myself. I've even decided what I want to make. This thing right here is my Ninja monitor recorder. It's what I'm recording this video on right now. Now normally these go up on top of a camera or something like that, right? We've got a 1/4-inch screw hole there, but I don't want this thing on a tripod. I like to be able to just set it somewhere that I can see it, but also be able to move it around. But with the battery eliminator and the hard drive on there and an HDMI cable plugged in, it wants to fall. So I just want to make a little stand for it. Something very simple. We can actually probably make use of our screw hole there to anchor it in. Just a basic little plastic cradle that will support this thing when I want to set it down. So modeling that, slicing that, printing that, and doing our temperature towers with the different filaments, if everything goes well with all that, that's probably the scope of this video. That's what we're going to try and accomplish. So let's start with getting our temperature tower set up. So one thing I forgot to mention is the PLA. I went ahead and vacuum sealed it. This is just standard Food Saver vacuum sealer bags. And I maybe should have stopped it before it pulled this hard, but you can see it got a nice seal. I put the desiccant pack that came in the original packaging, I went ahead and put it in there. So this is kind of my plan for storing filament to keep it out of the moisture. And the good thing about these bags, I'll be able to cut this off and reseal it 10 times before I need to replace it. Or I can just make the bag longer. This is from those rolls where you just cut it to whatever size you want. So that's the plan. So you'll see I put the PLA in this because, like I mentioned, it's been a few days. I wanted to edit the video up to this point. And since I started this, I turned, like it's the middle of winter, and I normally run a humidifier in my house because it gets really dry, but I turned that off and humidity in the house dropped down into the 30s. But after about a week of that, man, my nose never stops bleeding. So PLA got sealed up, humidifier got turned back on. And I'm going to be honest with you, I don't think it's a big deal on this short of a time frame, right? This is whenever you're either in an extremely humid environment or a package has been open a really long time. I get the feeling that's, when you should really worry about it, but I don't know for sure. So one of my viewers had sent me a link to some really nice plans for a dry box where you put this into a little humidity controlled box and then it just feeds into the printer straight from there. And I think I'll probably build one of those because just like the humidity gets low in my leaky house in the winter, it gets extremely high in the summer. So having a dry box is probably a good idea for me. So I had a live stream the other night and we were talking about slicers and the Ultimaker Cura. Here you go, ultimaker.com. This is the software that our Creality slicer is based off of. And this is the one most people were recommending. I was thinking it was the Prusa slicer. And I know some people have definitely recommended that one as well, but it seemed like Cura was the most popular. Now with my Ender 3 S1, the problem is it hasn't been added to the software yet. So Ender 3 and Ender 3 Pro are the options we've got for a generic setup. So I'm going to choose Ender 3. I'm going to go ahead and install this software. It installs exactly like the other one. And actually at this point, we might be able to open up the other one and just compare the settings for ourselves. So if I go up here and go to Manage Printers, and here's Machine Settings. Okay, so this is the exact same window we've got over here in Cura. It doesn't look like any of this is editable. Yes, it is. It looks like X and Y need change to 220. Z needs switch to 270. Yeah, it looks like those build plate sizes are the only difference, except Cura has got this additional option here, apply extruder offsets to G code, and it is enabled. All right, we'll go with it. We'll leave it checked, and we're done. I'm wondering, trying to see if there was a way to like duplicate. Yeah, add. That's what I should have done. I guess I could just go ahead and change the name here to add the S1. And I'm going to take a minute to look through all of these other settings. So if you remember earlier, we created the inland PLA material profile. So I want to do the same thing over here. So I created material profiles for inland PETG, PLA, and PLA+. Pretty big difference with Cura compared to the Creality slicer. If we look at the generic PLA profile in the Creality software, you look at this retraction distance is 0.8 millimeters. In Cura, generic PLA, it's 5 millimeters. That's a big difference. There's a little bit of difference in the retraction speed as well. Creality has 40 millimeters per second and Cura has 45. What I've done for my inland profiles is I matched what we've already seen works in the Creality slicer. They also have a lower default build plate temperature of 50 where we've been running 60. With all of these, build plate adhesion issues I'm having with things sticking too much, dropping that down might not be a bad idea. But at least for now, I'm going to leave it at 60, and the PETG profile is 70. The other big difference in the PETG profile is that the fan speed is set to 50%, where with the PLA, it's 100. So I think we're in good shape. I didn't see this earlier, but looking over here, I noticed that, so whenever I've got the PLA Plus selected, it doesn't even recognize that. It says there are no profiles matching the configuration of this extruder. I was going to go through and look at some of the other brands and see if there was a PLA Pro or PLA Plus. Yeah, it looks like there's a bunch of them. Like here's eSun PLA Plus, and that gives that same error. So, okay, so I guess that's what's going on. Is whenever you choose one that gets the yellow exclamation mark, you get not supported over here, and I guess you have to go to custom and do some of that stuff. Well, I'll tell you what, let's go ahead and just grab the files for the temperature calibration tower. So each one of these segments, it prints at a different temperature, and it checks overhang and the bridging that's been blowing my mind and the fine little points and stuff. So it just does a bunch of different tests at different temperatures. So I downloaded the file for PLA. There's one for PLA Plus and one for PETG. So let's open up, actually I want to open up the PLA Plus one. So the PLA one goes from 180 to 225 degrees. PLA Plus is 195 to 235. And PETG is 220 to 265. Well, our brand of PLA says the recommended temperatures are 215 to 230. We've already been printing at 200, so we know it works lower, but I don't feel the need to go all the way down to 180 with this one. So let's go with the PLA Plus tower, and maybe this will actually work for both the PLA and the PLA Plus. Because all the other settings between PLA and PLA Plus, right now at least, I want them to be the same. So we've got our dynamic quality selected, and as far as infill goes, I don't think there's any spots we're going to be doing infill. So let's just slice this and see what it says, or see what it looks like. So what I want to do is try and find out the exact layer where one finishes and the other begins. There's got to be a way to increment up and down one. Okay, yeah, up and down arrow. So layer number 85 is the first layer of the second segment. So I'm just going to start up a text document here. 235 is 1 through 84. Okay, so I think I've got all of my values. So for 230 degrees, that should begin on the 85th row, or 210 degrees should begin on the 393rd row. So if we go to 393, there's 390, 391, 2, 3. Yep, that's the first row of that 210 segment. So we want it to start at 235. And I guess the easiest way to set that initial temperature is over here. We'll make that 235. So hopefully that's good. Looks like we need to slice again. Hopefully that doesn't mess up my layer count. Let's see, 393 is the first. Yep, looks like it is. So there's 392, that's the last layer of that guy, and then there's the next one. Okay. So what we have to do at this point is go under extensions and go to post-processing and modify G-code. But you know what, before I do that, I want to save this one to disk. Let's call it PLA temp tower 195 to 235, and I'll save that one. Or I should have given that a different name. We'll call that before edit. Okay, now back to extensions, post-processing, modify G-code. It brings up these post-processing scripts, and if we add a script and choose the top one, change at Z, we can do things like change the extruder temp at either a specific height, or we can choose layer number. So obviously I want to choose layer number. And I saw somebody mention in the comments for this file that in the G code, the counting starts at 0. So where I calculated the 85th layer is our first one for 230, I think I actually need to put in 84. We'll see if we can figure that out, but I don't think it really matters all that much. So layer number 84, we want to apply this to the target layer and the subsequent layers. We want to change the extruder temp to 230. And then we need to add another script. Same thing, change at Z, layer number 161. So that's this one minus 1. We want to change the extruder temp to 225. Okay, I think I got them all here. So we've got 8 different changes, and I should be able to hit close. And we've got this little thing down here showing that we've got scripts to run, so we need to slice again, and we'll save that one to disk. That took a couple minutes to save, but our file sizes are exactly the same. What I wanted to do here was use a simple program called examdiff. I assume these are clear text files. Yeah, they're just plain text. So if I bring these over here into examdiff, we can look and see what the differences actually are. It looks like a little flag here that says there was post-processing. It's like just a couple lines here. I'm not sure what M and T are, but S230.0 looks like our temperature change to 230. And there's the next one, 225. So it looks like he's just adding a couple additional lines to make that temperature change. It's got me wondering. I'm not quickly finding an explanation for that. I'll have to look that up later. Not that it matters. I was just curious. Okay, so I want to take this file to the printer and run it on both PLA and PLA+. And then I'm going to create one of these for PETG, which we need to go a little bit higher in temperature. Okay, I think I got my PETG file ready to go. But the problem with this is it goes to 265 degrees, and my Ender 3 S1 has a maximum nozzle temperature of 260. So I'm going to start it at 260, and just these first two will be both 260. Then the rest will go like normal up to 220. I wouldn't mind going lower than that because, so the box for the PETG says 225 to 240. So I'm going hotter than I really need to. And I think I've read this PETG puts off funky fumes at high temp. So I'm not really all that interested in this, in the high temp side, and I kind of wish it went a little bit lower. But I think I'm just going to roll with this for the first test. Might as well test out that max nozzle temperature now anyway, right? So in my extensions, I've got all of these set up and ready to go. I've got my PETG profile selected, same dynamic quality, so we'll just go with this and see what happens. Now, one thing I should probably mention is that whenever you use these extensions, they stay there. So we could close this project, close the software, open it back up, these are still going to be here. So you either need to remember to come in and delete them, or you can uncheck this box to disable them. I think that's what I'm going to do because it's kind of a pain in the butt to add them. And once we uncheck this one, this should go away, I think. Okay. Yeah, it says the following scripts are active. So why is it still showing them active? They're not enabled. Whatever. I'm going to leave it like it is for now. So the next thing I want to do is go over into Tinkercad and start trying a very basic design for my little monitor holder. I think the best way to go about this since I have no idea what I'm doing, might be to just mess around here for a while and then check in with you guys once I get my bearings and start making some progress. Guys, I think I've got something I want to print. It's about as simple as it gets, but that's all I'm looking for. Just a basic little cradle for this monitor. Got a little locator pin sticking up there, which I'm still not sure I've got that placed right. But let me talk about some basics here. So the biggest revelation was learning that if you right click and hold it down, that's how you move your view around, and it makes life pretty simple. So we bring in shapes here from the right, and there's a lot of different stuff you can choose from. This has all been boxes and cylinders. So I'm sure there's a more elegant way to do this, but so like I want to chop the sharp top off of this. So if I bring a transparent box over, which it gives you the option to switch between a solid box or I don't know what they call it, like an elimination zone, change to hole. So they call it a hole. So I just want to chop a little bit off the top of this. So if I stretch this out, the next difficult thing that took me a while. So if you click at the white corners, it shows you numbers and stuff. And if you click here, it shows you the height, and you can adjust the height, click and drag, or you can put in a number. But I actually had to do a quick search to find out how to raise something above the workspace. And it's the little black arrow here at the top. If you click it, then you can go upward. So if we just leave that hanging, and then spin around here, should be able to drag that. It's a little bit clunky, like you kind of got to be just the right angle to drag things the way you want them. So that's going to chop that sharp point off the top. I mean, I guess I could probably just bring it down. I need to come down just a little bit farther. All right, I think that got it all. So if we eliminate all of that, I think we'll be okay. And to do that, I guess you select both objects, and then up here there's a group option. So if we group them, it'll make that change stick. And you can undo things and Control Z to undo a change. I like that better when it was a little higher. We'll give that a try. Or if I wanted a brace here, maybe we could make this thinner. So this is a whole bunch of grouped shapes. So let's say I wanted to make this thinner. I'm gonna go up here to ungroup. Yeah, I guess you gotta keep on clicking it until it ungroups everything. Not really sure. Yeah, I don't think it's going to give me access just to edit this. Or no, that's all that's selected. Okay, got it. So I select it, and now I can see its footprint below it. So if I just wanted to make it thinner, it doesn't really matter that I'm going to mess up that angle because I've already chopped it off anyway. So I think I could click here. No, why does it move the whole thing? It's Control Z. Yep, that ain't it either. Well, let's just do it this way anyway. So that makes it thinner, and then you can grab the angle here and tilt it back. Oh no, I need to select something that's inside of that something else. All right, let's just undo it. Yeah, all I've really done here is make a mess. Let me undo a bunch of stuff. Okay, I think we're back to normal now. Maybe it would be easier to do an elimination. I know what we could try. Yeah, let's see if I could pull that off. Okay, that's a start. Now, if I rotate it, the base stays. No! There's got to be a way to rotate it, or to change the anchor point, I guess, is probably what I need to do. All right, I'm just making a mess at this point, but that's okay. Made it a little thinner. Tell you what, let's go ahead and group that, which gives me this weird spot on the back that I need to fix, but that should be easy enough. We'll just sink a basic square right down in there and call it good. Yeah, that's fine. A little bit of a weird angle there, but that shouldn't be a Shouldn't be a big deal. Tell you what, just because the printer's busy printing the temperature towers right now, let's add something stupid. How about a brick wall? Oops, I think I accidentally added an extra one. Okay, let's, what can we do with a brick wall? Let's bring it over here, and let's tilt it. Crap. Let's try this again. Brick wall reinforced. Yeah, let's do that. All right, I need to trim the other end. I think this is the wrong square. Yeah, that's the wrong square. Control Z. Let's try another view. Okay. All right, that's pretty close. I don't like them poking out the top there, so let's see if we can... Actually, I would need to go down just a smidge, right? And then maybe bring it over. Okay, how's that? A little bit weird. Guess we'd go ahead and just get rid of that overhang. All right, I'm cool with this. Sweet. So what I need to do now is export. Oh, I see it's only including the selected shape. Let me make sure I don't have, yeah, we don't want anything selected. Let's try this again. Yeah, okay, everything in the design. Oh, it looks like you can send directly to a printer. That's pretty cool. We want the STL, preparing model for export. This thing's really taking its time. It's been at least a minute so far, I would imagine. There it is, and we'll save it. So in Cura, let's go new project and open my Cradle. We'll set this up for PLA. Seems like the safe bet. And for a first print of this guy, I probably don't want to go ahead and use the high quality. I want to use low quality. So we'll have to look at the infill percentage here. There's nothing that needs support, that I don't think. And can't imagine a big base like this would need adhesion. So let's go ahead and slice it. And there's still my scripts here. I'm going to get rid of these just to be sure. Don't want to screw something up. All right, let's slice it real quick and see what the infill looks like. So coming down, which I think, oh, there we go. You see how it's adding that infill to the interior parts. That seems like a lot of infill, especially for you know, just a test print, really. Yeah, let's remove that. Yeah, let's drop that infill a little bit. So right now it's saying 9 hours, 41 minutes. Let's put it to 10%. What I say, 9 hours, 40 something minutes. 8 hours, 2 minutes. And that's what it looks like. Let's do it at 0. Yep, here we don't get anything. So I can't imagine that would work, because those are some pretty massive bridges. Yeah, right here, layer 86. Probably not going to work out. All right, let's go back to 10% infill, slice it again, and now we've got our stuff back. All right, I'm going to save to disk. I'm going to finish my temperature towers and then print this, and then I'll check back in with you guys. So I don't have all the temperature towers done, but I wanted to skip this thing in line and get our first example printed out. So I have not test fitted this at all, so let's see if we're anywhere close. I already think we're in trouble. I don't have enough relief here for the power cable, I don't think. But let's see if this... Okay. My post is a little bit too big. Let's see what our clearance looks like. It's not too bad, but it's not too good either, right? Let me remove the power cable. assuming I can get this thing out of here. There it is. Okay, without the power cable. Yeah, once it gets to the proper angle, that post is just about correct. See what we look like back here. Like, listen, it ain't perfect. The post is too far forward, so it's swiveling on it. This part's too high, so we don't have power cable clearance. But listen, like, as a concept, that's good. It's doing exactly what I'm hoping it'll do. I definitely need to tighten this up, though, because, you know, working on the touch screen with it pivoting on there would be super annoying. I guess the design is just so simple that even low quality comes out looking okay. And there's a couple spots here. It did pick up some of the leftover plastic that had been sitting on my build plate. Like, it feels strong. I mean, heck, even this little thing right here, definitely flexible. See what it takes to break it. Yeah, that's pretty darn strong. Yeah, without a model of the monitor in Tinkercad, it was really kind of hard to judge some of these distances. Like, I think for that post, what I did was grab my calipers and just kind of try and eyeball that distance, because I think perfectly profiling this would be a challenge outside of my capabilities. You know what I'm saying? Too many small changes and little nuances. Okay, so that was a wonderful little failure. I want to get to work on revision number 2. Here is the PLA tower that has finished. The most obvious things I see, like up here at 195 and 200, see how we got some funky stuff going on there at the tip of our little spike. And then there's this area of pretty good from around 205 to 215. And then the higher temperatures, the bridges start falling apart. And we get some spaghetti going on in here as well. Like, looking at the different overhangs at the different temperatures, those look fine. And we definitely started getting a lot of wispy little hairs up here on the low end. Wasn't necessarily expecting that. So the PLA Plus test is running right now, and I've still got to do the PETG test. So I've got a couple hours to work on revision 2 before the printer's available. Okay, I think I've got 3 designs ready to slice up and try. This is the updated cradle design. Played around a little bit with some recessed lettering and adding some voids. So I'm not sure which one is more efficient, like trying to skeletonize designs or just leaving them the way they are and then relying on your slicing software and the automatic infill to take care of all that, right? It's going to print hollow, so hollow with infill may actually be better than something like that. I don't know. I thought it would be fun to print out and see. I think I've got the placement of my locator pin a little bit better. I widened this part, chopped this side lower to clear that cable, and then added these chains to hold everything up. So I did add a solid piece going through the middle of the chain, because I think this chain, actually I know this chain, if you zoom in on it, it's actual chain links. So I wanted to freeze all of those together. So there it is. Pretty goofy, but if the monitor fits well on it, I'll be happy. So I need to export this as an STL, and then we'll be ready to slice. So here is the second one. So I'm going to print it like this, which everything below the plane will get deleted. So a lot of little places I had to think about support, or making sure that one of the letters wasn't disconnected from everything else. I think I've got everything touching that needs to touch. But you know what, now that I say that, look at that C right there. Whatever, we'll leave it. But I did have to add this little support, or else this little guy would just be hanging out in the middle of nowhere. Should try and center this a little bit. Looks good right there. Let's export that. And the last one's right here. I have a feeling, this one in particular, but maybe the last one as well, will be pretty disappointing, because a lot of the details that are popping right now because of their color, we might not even be able to tell what they are. Let me see if I can change. Yeah, looks like I can change this. Yeah, that might not be too bad. So this design here, we're definitely going to need at least one support in the slicer to hold up the end of this F. At least I think so. So I imagine the slicer will create a support that comes down to the base here perhaps. I don't know, I thought it would be a fun test. So let's export that one as well, and we're good to go. Tinkercad has been a lot of fun to play around with. It's just figuring out how to move, and whenever you select something, figuring out what each of these dots is going to do. And there's a ton of stuff that I know there's got to be a simple way to do it, and I'm just missing it. Like I'd love to know how to just select everything and do rescaling. Although this one's not allowed because this skull head has got scaling locked. Because over in this fun and games section, there's all sorts of different pieces that I guess fit together perfectly, and they don't want you to be able to mess up the scaling. So that really set the size of this whole design, and I had to work around that. Tinkercad is kind of slow. Some of it may have to do with my pretty slow internet, but I don't think so. It's probably on their end. It wasn't really a problem. It just confused me at the beginning, because I would make a change and expect it to happen instantly. And sometimes, like if you're making a big change, it can take 30 seconds for it to take effect. Okay, let's go over to Cura Slicer. Let's open up the, tell you what, we'll do this one first, since I know it's going to need a support. Wow, it got mirrored, which I think is easy to change over here. Or am I losing it? Yeah, we're okay, I think. Boy, lost a lot of detail coming over from Tinkercad, didn't we? Maybe not. So far I'm done with the PLA and the PLA Plus temperature towers. The PETG is running right now. So I'm going to set this up for PLA, and we'll go with the dynamic quality. And we need to check support, because like I said, that F, I know we're going to need something. So let's see what that gives us. Holy mother of supports. Yeah, this is crazy. Could probably do with a lot less infill as well. Let me move infill from 20 down to 10. And let's see if I go to custom, let's see if there's any better adjustments under support. Generate support, support placement. Okay, it's set to everywhere. We definitely don't want everywhere. Touching build plate. Let's see what that changes. If just changing to touching build plate, yeah, that got rid of all of them. Okay, so let's go back to everywhere. But right now the support overhang angle is 51%. So I guess that means everything more than 51% gets, or 51 degrees. So I guess that means everything over 51 degrees gets a support. Let's try moving that to like 60. Let's see what we get. Still a lot going on. Okay, let's go crazy. Let's call it 80 degrees. All right, we're getting better. I guess the bottom part of that skull has just got some crazy overhangs, which we could go back to Tinkercad and get rid of this. Yeah, that's what's going on. And it doesn't look like we're going to have the resolution to fill out these fingertips. For some reason they're looking a little sparse. Let's open up the other one and see if it's also going to be a pain in the butt. The PLA, we'll tell it it can add supports, and slice. Well, doesn't look like we generated any supports, did we? That's good. Oh, there they are. So yeah, this one was supposed to be, I want to try and move some of this down below the build plate or whatever, but it's so frustrating just trying to learn how to navigate these programs. So the tip of the fingers over there is where I wanted. Come on. Okay, I think that's about right. So let's slice it again. Let's bring the infill down to 10%. It was about an 8-hour print just now. And it says about the same. You know what? Let's give it a shot. It looks like it didn't even try to do the trigger. No big deal for now. We'll see if we can actually get this off of the build plate. I bet we can't, like especially like the little fingers or this O that doesn't make much connection. I'm going to come back and work on this. It doesn't look right. The lettering looks totally different. Yeah, I want to take some time to work on that. But hopefully the new cradle for the monitor won't be quite as bad. I could probably go a bit deeper on that lettering, but that's fine. It's just a quick test. Looks like I'm one layer off, maybe, right here. Yep, and the remnants of our old brick wall there. Definitely some more cleanup I could do on this, but I don't want to. Let's go 10% infill. Stick with our dynamic quality. Actually, I need to set the print temperature, which I'm going to go with 210, and let's slice it. Which let's enable generate support and see where it puts it, or if it puts it anywhere. Yep, it puts supports under there and in our little hole. I'm just going to leave them off. We'll see what happens. I'm going to put it on low quality. There we go. Low quality, 210 degrees. Says it'll be a 9-hour print. So we'll see how that goes. So I'm going to take a little time, see if I can get one of these designs to go into the slicer a little cleaner. And we'll go from there, I guess. Okay, all 3 temperature towers are done. We already looked at the PLA tower a little bit, and the droops on the overhang at the higher temperatures was the main problem down there, and then up at the top, things get kind of stringy. So with these settings, 210 and 215 are what I think is the best. And the PLA Plus is pretty much identical. At the higher temperatures, we got the droopy stuff, a couple spots right there. And then up at the other end with the low temperatures, we got the exact same sort of nonsense going on there at on these two. So once again, 210, 215 looks the best to me with these settings. So pretty much identical performance with the 2 inland filaments. The biggest problem was the PLA Plus was a huge pain in the butt to scrape off of the bed. So I think I'm going to play around a little bit with bed temperature. I've been running at 60 degrees on both of these, so maybe something a little lower would help with the PLA Plus. Now, I kind of get the idea you want to be as hot as you can because that leads to stronger parts. I guess at lower temperatures, there can be problems with the layers adhering to one another and being weak, easy to crack, easy to delaminate. So maybe one of these days, I'll decide I want to start bumping up my temperatures, and then all of the other settings we've discussed could clean up the issues here. It's a lot like reloading. You change one variable and everything else changes, right? Bed temp, nozzle temp, fan speed, then all of that retraction distance, retraction speed, and so many more that I'm not even aware of. So here's our PETG tower. And if you'll recall, both of the two bottom ones are both 260. So 265 was too hot for my nozzle. We have got a mess. Look at these first few. And it really doesn't get much better until we get right up here to the last one or two. 220 and 225 are a whole lot better than the rest, but they're not quite good enough. Here's this other side starting from the bottom. The overhangs seem okay for the most part, or at least they're not terrible. It was navigating this bridge and coming to that little point that were a real struggle. So the default profile for PETG had the fan setting at 50%. So maybe trying a different fan speed and printing a couple of these, or maybe it's the retraction speed or retraction distance. I don't really know. And I gotta be honest with you, I don't think I really care right now. I'm glad I bought this spool to test with, and I want to get back to it and get it figured out. But right now I'm just having so much success with the PLA that it seems like the best use of my time is learning how to use the 3D modeling software and picking out which one I want to use long term, or playing around with the slicer and trying to figure out how to get it to make supports just like I want, those sorts of things. So PETG is just going to have to wait until I either come up with a scenario where I need it, because I guess its biggest advantage is more heat resistance. It can handle a little bit higher heat. And right now I just don't really have an application that demands that. So I'll just play with PLA until I get bored with 3D modeling stuff. So right now I'm printing out my two custom designs, and I'm going to go ahead and do them with the PLA Plus just because I'm tired of that color. Just want to make some green stuff. So I've got them set up for 210 and they're running now. So we'll have a look once they're done. So this came out awesome, but it's also a complete and total dumpster fire of a failure at the same time. So I showed you two designs earlier and just kind of distilled it down into one little pencil holder. So we'll come back to this guy here in just a minute. I can't wait any longer. Well, I better show you one of the big flaws before we try and put the monitor on there. Just a little bit of stringing there off of our little post, which is hopefully now in the correct spot. All right, moment of truth. All right, it goes on there. Hang on, there's no way I'm that dumb. I moved it the wrong way, didn't I? Actually, I need to go get the hard drive. Stand by. All right, let's slide that guy in. See if that changes things. Yeah, I think I'm a moron. But then again, maybe not. Maybe it's just pivoting right there. Yeah, that may be it. All right, let's check our power cable clearance. Should have plenty now. Oh yeah. Yep, plenty of room for the power cable. And I guess now that I think about it, my record button's on the left. I rarely ever tap over on this side, so maybe it'll end up being okay. Let's have a look at some of the other details. The chain links are not the prettiest thing you've ever seen in your life, but they're still pretty cool. A little bit of loose stuff there. The text came out pretty good. Remember, this was low quality, so a lot of this is just expected. Let's look at our hole through there. Got a little bit of drooping at the top. As it was closing that hole, got a little bit droopy. Kind of pretty happy with that. Yeah, pretty darn happy with that. All right, back to our pencil holder. This was the best way I could come up with. You know, both of the other designs I showed earlier were just unprintable, especially at my current knowledge level. So printing this guy like this was something I thought I could get away with. I was going to leave the whole box off and just print this last little bit, which is probably what I'll do as I continue to work on this and refine it. And then once I'm happy with the facade, I can add the container back in on the back. Because, okay, so most obvious failure is right there. So, you know, it was sitting on the build plate like this. So not a huge surprise. But I'd say my biggest failure at this point was that these walls are too thick and it printed them hollow. It seems like maybe going thinner and solid could reduce the print time by a bunch. So problem number one, wall thickness, way off. Just wasn't even really paying attention to it. Wasn't even thinking about it. The next part I wasn't expecting is whenever it got to the front and started doing some of the details, like all hell was breaking loose. It was leaving big voids and doing all sorts of crazy bridges on some of the gaps. So I really didn't think it was going to come out, but it did. So biggest problem on the front, we got a couple strings going between the skull and the gun, which should come loose pretty easily, I imagine. And you can see a little closer what I did with the skull. I gave him this big double chin. Well, at the time I was going to be printing it this way and needed to get rid of that chin overhang. So if I'm going to continue to print it this way, I could basically eliminate that. I kind of like him with a double chin though, right? He's more relatable. You can also see inside of the eyes and down here in the cheeks, there's a perfect sphere back there. Like all of the voids and the minor details inside, that was the best way I found to get rid of most of them, was just to create a sphere in Tinkercad and then sink it inside the skull and bring it out as much as I could without, you know, losing the detail I needed. And I think that actually worked out really well. So I'm going to be doing a whole bunch more work on this because I kind of like the design just as a concept. But since all of the individual parts came out of Tinkercad, I'm not really sure what the licensing terms are. So I want to start from scratch and do just kind of a totally original design. Especially like the skull is locked in so I can't scale it any larger. So it's another good reason why I just want to make another one. So I'm going to keep working on this one. Hopefully clean up all of this stuff, but then also nail down some better methods for the walls like I mentioned, and get something that would print a whole lot faster. This took forever. I think it was 13 hours or 12 hours, maybe something like that. So if you want to follow my progress, I did create an account over on Thingiverse. So I'll make sure to leave a link to that in the description, along with a whole bunch of other links from just about everything we talked about today. As far as the build plate goes, it looks like I can get a replacement for $12. So not a big deal there. And you know, this one I'm sure has a lot of life still left in it. And the more I scrape it, the smoother it gets. Things do seem to be coming off easier. You know, that brand new surface that's very gritty was just a nightmare. So maybe you already have a 3D printer. If you've had problems getting stuff to stick, man, try this out. And apparently when you buy them, it comes with both, you know, this part and also the magnet part that goes on the bed. So it seems like it's pretty easy to retrofit this stuff. One thing I don't know is, like, if I wanted to try a glass bed, I'm not sure what steps I would need to take. I assume it would probably be very simple. So this was exactly what I was hoping for, right? Straight out of the box, and I'm immediately having success. So I don't know how I could be upset about the Ender 3S1. It's done everything I've asked for. So I think that's pretty much it. Hopefully somebody out there will find this helpful or entertaining. Pretty darn easy to get started. I'm pretty excited that I can, you know, focus in on the modeling and efficient slicing and that sort of stuff instead of the non-stop tinkering that I thought might be necessary. All right, that's enough for now. See you guys next time.